All right, so everyone. So again, this is the last lesson in this optimization unit. We're going to continue our curriculum by talking about polynomials on Monday. For your aim, it's how do we optimize an area bounded by a curve? And you might think that this is like a really specific topic, but it has, great importance because in calculus next year, or if you take it in college, right, like the second half of calculus is this concept of integrals, which is essentially just taking the area, finding the area under a curve. Okay, so we're going to get to, the start of that idea in today's lesson, in this pre-calc lesson. Okay, but yeah, for your do now, it's a rectangle is inscribed in a semicircle of radius 10 that is centered at the origin. Find a function that models the area A of the rectangle. Okay, so to start us off, try to think of the equation of the circle, right? So if you remember the equation of a circle, it's like x minus h squared plus y minus k squared equals r squared. Okay, so you have the center, you have the r value, and then think about what it would mean to find the equation for the semicircle. And then that'll help us find the function that models the area of the rectangle. Okay, so take a minute to do that, and then we will discuss. Okay, so hopefully you have come up with an equation for at least the circle and then eventually the semicircle. Okay, let me scroll up for the solution. Okay, all right, so here's the equation of the circle, right? That's described here, radius 10, center at the origin, right? So it's x squared plus y squared, right? H and k in this case are both 0 because the center is at the origin. And then the radius is 10, right? So it's 10 squared. Now, to find the equation of a semicircle, we're going to have to isolate y. Okay, so we get y squared equals 100 minus x squared. And then we're going to take the square root of both sides. Okay, so we get plus minus square root of 100 minus x squared. And as I write here, it says the equation of the two, these two equations, it's plus minus, right? The equations of the two corresponding semicircles. Okay, so the positive one is the one above the x-axis, and the negative one is the one that's below the x-axis, right? But we're going to take the positive one because, as we can see here, the circle is above the origin, right? Or rather, the semicircle. Okay, now you might be wondering why we need to find the equation of the semicircle. The reason for that is, like, how does this relate to the area of the rectangle? So the reason it relates is because here we have, let's say we have a general coordinate, right, x comma y, right? The y coordinate is actually going to be the same thing as the height, right? So because even if the rectangle varies, like let's say the rectangle looks like this, right? The coordinate, right, is going to be equal to the y variable, right? That's equal to the height of the rectangle. Okay, so that's what we're trying to find, the equation for the semicircle. Okay, so the y coordinate is equal to the height. Okay, so y equals the square root of 100 minus x squared. We're taking the positive one because, again, it's above the origin, as you can see from the diagram. So that's the height of the rectangle. The length of the rectangle will be double the value of the x coordinate, or 2x. All right, so let me explain that. So the reason why it's 2x is because here's the origin, right? So it says the semicircle is centered at the origin. So this is 0, 0. And this, if we have like an x, an x coordinate, right, like here, this point x comma y, right, then this distance is equal to x, right, and then this distance is also equal to x. I know this is technically like negative x, but right, the absolute value, the distance, is equal to x, right? So therefore, the length of the rectangle is 2x, and the height is y, which we got here. Okay. So therefore, we can just multiply the two quantities. We get 2x times square root of 100 minus x squared. Okay. And I know the question didn't ask for it, but if you wanted to, you could find the vertex using calculator by plugging this function in. But yeah, this will be your final answer right here. 2x squared of 100 minus x squared. Okay, I'll give you a sec to copy that, and then we'll move on to the classwork. Question?
Yeah. So when I first looked at, like, I get how this works, but when I first looked at this, essentially h times and then 2 times 10 minus h to find the 2 times 10 minus h was the length of the rectangle. So eventually, like, the function I ended up with was f of x equals 2h squared plus 20h. Would that end up the same answer as?
Okay, wait, you said 2 times 10 times h?
Yeah. No, it was to find that length there. I did 2 times 10 minus h. Oh wait, I see why that's wrong. Never mind. Yeah, never mind.
Okay. Yeah, I'm not sure if I heard everything. The audio is kind of spotty from my end. But
Oh yeah, that
if I'm hearing correctly,
yeah.
yeah. So I think this length is 10 here. So this is not equal to half the length of the rectangle, right?
Mm,
So this technically this would be 10. So you could use like this to solve, but this would be like more complicated. Like this would be, you know, I guess you'd use that. That's the hypotenuse of this right triangle. This is h, and this would be x, and then yeah, yeah. I'm not sure. Like, it might be the same, but yeah, I
No,
would
no,
just
no.
recommend
I
using
actually
X.
read. I did the problem wrong. So
Oh, okay. All right. No worries. Yeah. Um, but yeah, I remember like last year, one of my students did it this way. There was still a bit of solve it. But yeah, I think this would be the simplest solution. If in case anyone was thinking about using this method, which isn't wrong, but yeah, just this is the simplest one. Okay. If no one else needs the solution, I'm gonna bring us to the classwork. So the classwork is 3 questions right over here. Okay, so questions. So there's 3 questions. Questions 16 and 27. They are, they're relating to the aim, right? Area under a curve, just like they do now, right? Question 17, the second one is more of a physics question, right? So you're gonna find the height of the ball at various times and then maximum height, right? So yeah, question you might have seen in physics class, but yeah, there is some overlap between the two classes. So, anyways, I will give you. So there's 14 minutes left in class. I'll give you, say 7. Let's say 7 minutes. So 1:43, we'll reconvene and discuss. And in the meantime, I'll draw some diagrams for 16 and 27 to help you along. All right, so just FYI, these are the two diagrams for 16 and 27. Hopefully that helps, but yeah, we'll discuss in like 5 minutes. All right, so let me pause you here we're gonna just go over the solutions. For question 16, we have the following. All right, can I get a volunteer to read the question?
A rectangle has two lower corners on the x-axis and its upper corners on the curve y equals 16 minus x squared. For all such rectangles, what are the dimensions of the one with the greatest area?
All right, thank you for that. So here I drew a diagram. Here's this parabola, right, 16 minus x squared. And then the situation is that the rectangle has two lower corners on the x-axis, upper corners on the curve, right? And then we're trying to find, for all such triangles for which this is true, right, there are others, right, that we can draw, like, for example, like this one. Right, for all such rectangles, what are the dimensions of the one with the greatest area? Okay, so this is really similar to the do now, right? But a little simpler because we don't have to find the equation for the semicircle. But if we have, the length of the rectangle is x and x, so 2x, and then the height of this rectangle, right, given that this point is x, comma y, right, the height of this rectangle will be equal to actually the parabola, right? So whatever x value is, right, we can plug that into y equals 16 minus x squared. And since the rectangle, the corners are on the parabola, right, we can equate that with the height of the rectangle. Okay, so it's going to be 2x times 16 minus x squared. And, whoops, let me move this down. And yeah, as you can see here, you can use a calculator. In this case, you actually have to use a calculator because this is not a quadratic, so you can't use negative b over 2a. But if you do, you're going to find that it's 2.3 comma 49.27. Now you have to be careful here. The dimensions are what they're asking for. So like we have x equals 2.3 units. So that's what this coordinate represents, right? And then the y coordinate represents the area, so it's 49.27 square units. We're trying to find the length of the rectangle, so that's 2x, right? So it's 2 times 2.3, which is 4.6. And then to solve for the height, you have 16 minus x squared, which is 16 minus 2.3 squared, which is 10.7. Okay, so the final answer is 4.6 units by 10.7 units. Yeah, they don't give units here, so just write it as a generic unit. Okay. All right, I'll give you a sec to copy that, and then from there we'll move on to question 17. All right, anyone still need to copy this? You can type in the chat or speak up. Okay, if not, then I'll move on to 17. So here we have baseballs thrown straight up, and its height as a function of time is given by the formula h equals negative 16t squared plus 32t. H is in feet, t is in seconds. Okay, so part A and part B, we just find the height of the ball when t equals 1 and 1.5 respectively. So part A, we have t equals 1. So we literally just like plug in 1 into the equation, right? So we have negative 16, parentheses 1 squared plus 32 times 1, which ends up being 16 feet. Okay, that's part A. Part B, it's t equals 1.5. So again, plug in 1.5 into the equation. You're going to end up with 12 feet. Okay, for part C, we're going to find the maximum height of the ball and the time at which that height is attained. Okay, so here we can actually use negative b over 2a because this is a quadratic. So it'll be negative 32 divided by 2 times negative 16, which is negative 32 over negative 32, which is 1. All right, 1 second. I guess technically this should be t, but yeah, t equals negative b over 2a. and then we plug in 1, right? But if you notice part A, we actually already solved for, the height when t equals 1. It's going to be 16. Okay, so yeah, the maximum height is 16 feet, and it's attained at 1 second. All right, next we have part D. What time is the height? 7 feet. So for this one, we set h equal to 7 and then solve for t. Okay, so 7 equals that equation. And here we actually have to use the quadratic formula. 16t squared minus 32t plus 7 equals 0. So apply the quadratic formula to this. And you're going to end up with this expression here, 32 plus minus 24 over 32. So the two times you're going to get are 1.75 seconds as well as 0.25 seconds. Okay. That came from like 32 plus 24 divided by 32, that's 1.75. And then for the other one, it's 32 minus 24 divided by 32, that's 0.25 seconds. Okay, so on its way up, it reaches 7 feet. On its way down at 1.75 seconds, also at a height of 7 feet. All right, last but not least, we have at what time will the ball hit the ground? So for this, we set the equation equal to 0. So we have 16t squared minus 32t equals 0. So from there, you factor 16t, and then you get 16t times t minus 2 equals 0. So 16t equals 0 or t minus 2 equals 0. So t equals 0 or t equals 2. Now, the only answer we're going to accept is t equals 2, right? Because, t equals 0 is when the ball was thrown, right? So that doesn't count, right? Because this is asking for, like, when will the ball hit the ground, right? So that, that assumes that, like, that implies that the ball was already thrown. Okay, so the answer to that is t equals 2 seconds. Yeah, t equals 0. We will consider that to be extraneous. All right, let me clear this. All right, but yeah, so I posted the lesson plan on Google Classroom if you want to check out the last solution. You can also stay after class, but I don't want to hold you past the time. But let me close with announcements. So yeah, the only announcement is that there's SGI today, 2:47 per usual. And yeah, if you're done copying this, you're free to go, and hope you have a great weekend. All right, take care.
Thank you. Have a good weekend.
Have a nice week.
All right, you're welcome. Thank you, you too.
Have a nice weekend.
All right, thanks, you too.